Okay, let's begin with question number 7. Okay, from this paper. All right, so this is going to be the question. Let's move it to the whiteboard so we have more space there. And let's start. So diagram shows a circular cross section. Okay, we got a circular cross section of a uniform cylindrical log. Okay, the center O and radius 20. So the point AXB lie on the circumference of the cross section, and AB is 32 cm. So show that the angle AOB is 1.855 radians, correct to 3 decimal places. Aha, so this is number 7 now on the paper. Okay, let's try this first part, please. Okay, let's take a closer look. How do we show this thing? So the first thing we notice is that this is an isosceles triangle. So I'm going to mark it like that and call it like this. OA equals to OB, because this is radius 20, then you can just put in the bracket like that to give a reasoning. Hence, so triangle AOB is isosceles. And then the next part, because we got isosceles, sorry, just got mixed up the spelling. Isosceles like that. So because it's an isosceles, we got a shortcut. We can use even a cosine rule and all that. Or we can use this shortcut. I just use a shortcut because it's a bit more interesting. So we can, not really a big shortcut of one, but still it is. So we can put the isosceles triangles have this property in geometry where we can just drop a perpendicular like that, and it would be exactly at the midpoint. So being at the midpoint here means that these two parts will be equal, which is the AB in the picture is 32, so the 16 each. So let's say we call this angle is alpha, then these two parts are being the radius and this is equal. I should mark it double like that to make it match with that picture. So 20. So just the midpoint. So if I want to give a letter to that, let's say I just call it M, just for the sake of completion. So we can do a sine. Let's say I do a sine because it's opposite and hypotenuse. So the opposite of this angle would be the 16 here. The hypotenuse is always opposite 90-degree angle, which is 16. That is the reason why we use sine. So katoa. So in that short form abbreviation. So sine opposite of hypotenuse. So we take sine alpha is 16 over 20 in this instance. So therefore alpha is the arcsine. We call it arcsine of 16 over 20. So let's use a calculator and calculate that, please. So shift sine 16 over 20. Ta-da! 16 over 20 is, so we get 53.13 degrees. So they want 3 decimal places. But here I see 53.130. So it's okay lah, 53.130 in degrees. So if the alpha is converted to degrees, now what we want to do is we want to calculate the angle AOB. So looking at the symmetry in the picture, now I talk about the AOB, or it will be 2 alpha. So we can write angle AOB is equals 2 alpha, which is 2 times this 53.13 in degrees. So this is in degrees. So I'm just going to point that out a bit in detail. So this is 53.13 on the next line, because I'm going to do it in one go means, so you can just straight away just times to convert it to radians. So you just multiply by a factor of pi over 180 to change it to radians, because pi radians is 180 degrees. So when we key all of this in a calculator, we should arrive at the answer. So I'm just doing that right now. Ta-da! And we should get that, you'll get in the calculator something like this, which is 1.854590436 according to the display. Then since we are going to round it through, what is it? 3, correct to 3 decimal places. Decimal means after the decimal 1, 2, 3. So you see the beside here. So it's about 1.85, the 4 plus 1, because the beside is 5. So it comes in. This becomes the answer as required. So this is already part 1 of this question. Okay, correct to 3 decimal places. Okay, now I'm just going to clear these drawings. Ta-da. Okay, and do the second part. So let's try to do that, please. So find the area of the sector AXBO. Okay, I'm going to find the area of the sector AXBO. So if I were to shade it, just to shade and remove it, we're talking about this part. So as usual, the earlier part of the question, will link to the current part. So in the current part, how do we link that is that we must assume that this angle is already known. So we have 1.855 in radians. Because it is in radians, so I would like to use the area of a sector formula in radians, which is half r square theta. Okay, repeat that, half r square theta, theta is in radians. So that means in this formula, we can write the area of the sector AXBO. Aha, you just use the word sector. If no, it will imply a quadrilateral. Okay, so half, the radius is 20, this number, radius of a circle, OA. So let's say we take that, 20 square, and the theta just copy from there, 8.55. This is in radians anyway. So we use the earlier part. So the earlier part, 8.55, whatever the approximation they have used in the question, please use that because the answer scheme would most likely follow like that. Huh? And then we get a nice number. See, they planned it out. It's 371. Aha. That's how you know that the area is 371 centimeters square. So this is the second part. We clear this up. Please take note. Okay, so let's go for the third part, please. After finding that out, so we're going for the third part. Sorry, we just recap that and write the answer. Forgot. 371, 371. The reason why I'm writing that, maybe it might be used for the later part. So good to write down like that. If we remove the screen, of course, in the original exam, you have it there. So you can just recap that. And here we are. Let's try the part 3, please. So on part 3, let's take a closer look. So the section AXBCD. So AXBCD, is it like that? No, wrong. Because we must follow according to the line. Huh? From here to here is an arc of a circle, BCD. Aha, to the A, yeah? So it returns back. So just we are looking envelope-like thing with a bit of a curved top there. Is where ABCD is rectangle with AD is 18. Okay, so we got this part. This is AD is 18. This is the part there. Is removed. So they cut this whole thing out. Oh, so find the area of the new cross section shaded in the diagram. So in other words, we're going to find the area of the shaded part in the diagram. So how do we go about it? This part, this is the part where I guess a little bit difficult, isn't it? Because we need to find, because we already found this area. Please take note. I'm going to label it a bit in coloring like that. Let's say in red. So we have something like this. The red part here. This is the, what am I talking about? AXBO, AXBO, the area of the sector. This was the 371, right? Just now. Okay, 371. Okay, so if it is 371 there, and then how do we find the area of the shaded part? So we have a bit of a complicated thing there. So it looks hard, right? You know, so this is where the thing gets a bit interesting because the easiest way, of course, there's no easiest way. It depends on how we define that. Just kidding. Okay, it depends on how you're going to look at it. That means I can actually find this part first separately. So I'm just going to change some colors so that you can understand what I'm talking about. Let's say this brown part here, because if I can get that, the area of the rectangle is easier to calculate. The second part again, I can split it to that. So the area of the segment, okay, this is called a segment. Segment AXB, Malay we say tempering, okay? AXB will equal to, area of, I write in word first, sector AXBO minus area of the triangle, AOB, isn't it? Oh, that is why we used the 371 from the earlier one. Now it makes sense. Usually it'd be linked. Okay, most of these exams, the early part of the question will be linked. They won't tell you that. Sometimes they'll tell you the result from the first part and all, but it's understood. So we want to use the area of a triangle formula, which is half r square in this case, sine theta, theta in radians or in degrees, sorry. Normally in degrees, but it doesn't matter. You can change your, what do you say, the angle to radians. That's why I said that. So 371 minus, let's say this is 0.5, the r is 20, radius square, sine of 1.855 can. Your calculator does input radians. So let's say I change the mode to radians and calculate this. So it's just a calculated thing now at this point. And when you key in the calculator, you should get this area of the segment AXB should be how much? Okay, we're going to calculate them manually, I guess. Okay, so let's see. So let me just put this in calculator. Let me change the mode to radians. Aha. So, give me a minute, please. So I'm just calculating. Oops, sorry, put the wrong constant. Sorry, wrong number. Yeah. Down. Let's learn this kind of things. Okay. So that means 0.5. I got confused with 371 minus. So 0.5 very key in register times 20 square times sine of 1.855. Ta-da! All right. So we have the number here as 179. So 179. And since they put the earlier one in 3 decimal places, I would personally put it in 3 decimal. I'll follow 023 for accuracy. Yeah? Just follow one of the statements there, although it's not applicable, maybe. Doesn't matter. So this is the area of the segment part. And then we want to calculate the area of the rectangle. So if I were to put it like this, ta-da! Okay, area of the rectangle. So I'm going to write somewhere in the top right corner here. Area of the rectangle A, B, C, D. It's just the length times width. That's the easiest part here, I think. 18 times 32. So please calculate that. 18 times 32 would be 576. So we have this, we have that. Then we can see that the area of the unshaded part is in the circle. So area of the unshaded, sorry, wrong spelling. So right here, based on all this, now we recap, we collect the information. Unshaded part of the circle is understood by the context is just this area of the segment AXB. So from which we get the value 179.023 there, that same color, plus the area of the orange part is the rectangle ABCD, which is 576. So we have 576 plus 179.023. So this becomes a total of the unshaded part is 755.023. 755.023. So this is how we get this area of the unshaded part. So finally, we can calculate the area of the shaded. So it becomes a bit simpler at this point. When we get that, oh, it must be the area of the circle, the entire circle, minus this area of the unshaded part. Okay, so the only last thing we need to calculate is pi r square for the area of the circle, which is pi 20 square. And the unshaded part, we just pick up the values you just calculated, 755.023. When you subtract this, we should arrive at the answer. So pi times 20 square minus 755.023. So calculator work, and this should result in the answer, which is around 501.61. 501.61. Okay. Done. I think they don't really bother about these decimal points or what, unless they specify. Not very sure. Normally it's 3 significant figures, quite a standard. So if it's not specified, maybe you can write both like that. Maybe it's 502 and a cm square. Please say that. So this is how we do this question. Thank you.